A geometric progression, GP, also called a geometric sequence, is a sequence of numbers which differ from each other by a common ratio. The common ratio is the ratio between a term in the sequence and the term before it. For example, the sequence 2, 4, 8, 16, and so on is a geometric sequence with common ratio 2. We can find the common ratio of a GP by by finding the ratio between any two adjacent terms. For instance, here, if we divide 4 by 2, we will get 2. If we divide 8 by 4, we will also get 2. In a geometric sequence, the nth term is given by an equal to a1 multiplied by the common ratio raised to power n minus 1, where a1 is equal to the first term, r is equal to common ratio, n is equal to number of terms. So if we want to find the nth term of a geometric sequence, we will use this relation an equal to a1 times r raised to power n minus 1. Now let's work out some basic examples that can familiarize us with the above definitions. Examples: the first example is 1. What is the nth term for the GP for 12, 36, 108, and so on? Now we are going to find the nth term of this sequence. The first term, a1, is equal to 4. The common ratio r is equal to the second term divided by the first term, and this is equal to 12 divided by 4. That gives us 3. We can equally use the third term and the second term, or the fourth term and the third term. Any of them is okay. So the common ratio is r, then the nth term is an equal to a1 r raised to power n minus 1. a1 is 4, so we have 4 times r is 3, so we have 3 here, raised to power n minus 1. So this is the nth term for the geometric sequence given in example 1. Now let's take another example. Example 2. Find the 11th term the geometric sequence (64 minus 32, 16 minus 18, and so on. Now in this second example, we are given a sequence which has 64 as the first term. Solution: first term is equal to 64. Common ratio R is equal to, let's use second term and first term, minus 32 divided by 64. So this will give us here 1, here is 2. We have minus 1 over 2. So the common ratio is minus 1 over 2. Then n is equal to 11, since we are asked to find the 11th term. So an is equal to a1 multiplied by r raised to power n minus 1. So if we substitute the values, we will have a11 is equal to 64 times minus 1 over 2 raised to power 11 minus 1. So this will be equal to 64 into minus 1 over 2 raised to power 10. So if we simplify further, we will have 64 can be written in powers of 2. 64 will be 2 raised to power 6 multiplied by 2 raised to power minus 1 raised to power 10. So we have written 1 over 2 as 2 raised to power minus 1. Then the minus sign here will be taken care of by the exponent 10. So this will be equal to 2 raised to power 6 multiplied by 2 raised to power minus 10. And this is equal to 2 raised to power 6 minus 10. We just applied one of the rules of indices. Numbers in the same base. When numbers in the same base are being multiplied, you simply add the powers or the exponents. So that's what we did here. 6 minus 10 will give us minus 4. 2 raised to power minus 4. So this will be equal to, now if we write this as a fraction, we will have 1 over 2 raised to power 4. 1 over 2 raised to power 4 is 1 over 16. So this means that the 11th term, A11, is equal to 1 over 16. Alright, we are going to end the video here. I hope you have found value in this video. If you have, please hit the like button and also subscribe to this channel for more interesting videos. Thank you.